Greetings, YouTube. Beautiful mind here. I just received this a question here in my email. It says, "Hi, I really need help. I'm currently stuck on a problem that I cannot move forward with." It says, "Write an equation of the line through -3, 1, and 5, comma -5 in standard form, knowing that standard form is ax plus by equal to c, where c equals 0. There is no room for these numbers. Please help." Okay, so let's take a look at this. Right. Let's see. I'll just try to be as short and brief as I can be. So typically when I'm working with lines, I typically have three equations ready to go. So whenever I'm working lines, the first one I have is the slope intercept formula, and that's just the basic y equals mx plus b, right? The second equation of a line that I usually have ready to go is the slope formula, and that's going to be the slope equals y2 minus y1 over x2 minus x1. So given 2 points, we use this formula to find the slope between 2 points. And then the third one is point slope form. Point slope form. We use this when we're given a point and a slope. That's going to be y minus y1 equals m times x minus x1, right? So I've had students, I was trying to do a different format, but I think I'm going to just go back to my regular format. It's much easier. So sorry about this. I was going to crop all that out, but I was like, it's not necessary. Yeah, so if we look at this example, we have the two following points. We have -3, comma 1, and we have 5, comma -5. So whenever I'm working lines with points like this, I automatically just label them in the following way. I'll go x1, y1, x2, y2. So then the labels are pretty clear, right? So with something like this, I would start with equation 2 to find the slope. And then once we find the slope, we'll have a point and a slope. So we could use equation 3 and then finish with the standard form. I'm going to choose the route that I think is more simple. My students actually use a slope-intercept form. They started with equation 2. Once they had the slope, they plugged one of the points in and the slope into equation 1, and then they solved for b. So I'm just going to choose a route that I think is more simple, what the students kind of showed me in the past. So first, let's find the slope. Again, one of my mentors said every time we use a formula, write it down. So again, the slope formula is this. That constant repetition of writing the formulas helps to ingrain it in our memories. You'll start to notice it has a rhythm or a frequency or a pattern, and so then it becomes second nature. This game of mathematics is all about pattern recognition. What we do the longest, we do the strongest, right? You don't do something once and you've mastered it. No, you have to do it over and over and over. Anything in life that we've gotten good at, we've done it over and over and over. And honestly, anything in life that you want to become good at, you got to do over and over and over, right? We didn't become who we are overnight, so it's going to take equal or greater energy to kind of change our patterns or whatever. So anyway, so using this formula, we can plug in the y2, which is, so here's going to be our y2 minus y1 over x2 minus x1. Notice I use a set of blank parentheses, and I'm going to put my numbers into the blank parentheses. The blank parentheses help us to keep track of our negatives, right? So our y2 is -5. Our y1 is 1. Our x2 is 5. And our x1 is -3. Okay? So if we account for these changes, -5 minus 1 is -6. Down here, we have a double negative going on. So double negative becomes positive. 5 plus 3 is 8. Both of these are at least divisible by 2, so this becomes 3 over 4. All right? So this is our slope. Okay? It's getting a little fancy here. Let's just go like this. Okay? So we have our slope. So now that we have a slope, now we can choose to use either equation 1 or equation 3. I challenge you, whichever equation I decide to use, maybe try using the other equation. You should still be able to get to the same answer. All right? Okay. So we got a slope, we got a point. We could use equation 3. I'm partial to equation 1, so I'm going to use equation 1. So again, every time we use a formula, write it down. So we have y equals mx plus b. We just found our slope, right? We said the slope was a -3/4. And we're going to choose one of the points. I'm going to choose the first point. Yeah, that's fine. So in the first point, my x is -3. My y is 1. And the only thing we don't know is b. So we could solve for b. Okay. So if we go ahead and simplify, double negative becomes positive. This gives us this, 9/4. Okay. Most professors allow, well, I can't speak for other professors, but be clear on if your professor allows you to use calculators or not, right? So how I multiply this fraction, if that makes you uncomfortable, I would just use the calculator, right? If you're not allowed to use calculators, then you should definitely bone up on how to multiply fractions. Yeah, so we're going to let that be, and then the b comes down, all right? If we're going to get the b by itself, we're going to subtract the 9/4 from both sides. Okay. Again, if you're not comfortable adding and subtracting fractions, I would use my calculator. Ultimately, let me see, 4/4 minus 9/4 is -5/4 equals b. So now we have our y-intercept. Our y-intercept is -5/4. Okay, this guy right here. All right, so we got our b and we got our m. So now let's go back to our formula. I'm going to do this one like this. Just changing the color to just get it pop, to get the image to pop. I'm going to go back to this y equals mx plus b. We just found our slope, right? So the slope we said was -3/4 x, and then our b was -5/4. Now a couple of more steps and we're home free. If we're trying to get it in the form ax plus by equals to 0, let me see. I don't know that it's necessarily going to equal to 0, but equals c. So let's clear out the fractions. We can clear the fractions by multiplying the left and the right by the LCD, right? So if we say this, the LCD for the fractions here is just 4. So the right by 4, and the left by 4. Let's do this and see what happens. Okay. So then on the left we get 4y equals, we're essentially going to have this. I'm going to show all the steps for the sake of instruction. We have the following. So when we distribute this 4, we'll get that first thing times 4, and that second thing, this guy right here, times 4, right? So we have a 4 on top. This cancels this, and that cancels that. Ultimately, we'll get here. I know I'm going a little fast. Keep in mind, you can like pause, slow down, rewind. That's the beauty of like watching videos, right? You can always pause and slow down and watch it at your own speed. You can even slow down the speed. Okay, let's move the x to the left to make the leading coefficient positive. So I'm gonna add my 3x to both sides. Okay, those are unlike terms, so they stay separate. Ultimately, we'll get 3x plus 4y equals -5. This is standard form. I don't think it necessarily has to be equal to 0. I think that's something else. Oh, and let's go like style. We want the fill to be blank. And like that looks good. And then what I'm going to do, actually, I guess it doesn't matter. Well, it won't hurt. I'm just going to shrink all this to one page. Okay. So hopefully that looks pretty good. So again, one more thing. The thing that actually made me fall in love with mathematics is the ability to check something of this nature, right? So if we're saying that this is the standard form, what should be the case? How could we check something like this? Only other thing I could see, if we wanted that C, let me think about it. Yeah, we can't really get C to be 0 here. Yeah, I'm going to leave it like this, but let's check really quickly. So standard form is usually ax plus by equal to C. I'm still not convinced that C has to be 0. It's not always 0. But if this is true, if we take those original points, the -3, 1, and the 5, -5, and plug it in, it should be true, right? I'm actually going to check this in my graphing calculator. It's not ready to go, though. Yeah, that's okay. I'm not going to use that. I was going to use the calculator, but that's okay. I'm going to do a quick check over here. I guess we can just do it mentally. So then 3 times negative 3 is negative 9, plus 4 is indeed negative 5. 15 minus 20 is indeed negative 5. So those x and y's both work in this equation, okay? So that's how I would do that. Hopefully that wasn't too fast, and hopefully it wasn't too all over the place. I tried to give you what I felt like you needed. Yeah. Okay, and so on that note, we will end the session here. And from one beautiful mind to another, enjoy the rest of your day. Happy studying.